day 2 of RSA, and I'm talking to Benjamin Jun of Cryptography Research. And today you gave a talk on anti-counterfeiting techniques. Could you tell us a little bit more about what counterfeiting techniques in particular you were talking about?
Sure. So today's talk was about, first of all, systems that tend to get counterfeited. We focused on embedded systems, systems that faced high threats. What are things like cell phone batteries, things like medical test devices, glucose test strips that have been counterfeited. We also looked at things like unlocking software. Generally in today's world, hardware is incrementally free. And what differentiates your embedded device tends to be the software that's running on it, not the hardware itself. So there are a lot of attacks that involve either copying your software outright or finding ways to convince your software that it's authorized to do things that you haven't quite paid for. We also look at other comparable things like cloning cell phones or cloning RFID tags. And essentially, the challenge is how do you create a device that uses software in an embedded system in a way that's difficult to upgrade, reverse engineer, or counterfeit.
Well, let's dig deeper into one of those areas. How about the medical glucose test strip system? How would somebody defeat that?
Sure, let's first talk about the business model and why this is an interesting problem. When you go and buy a medical glucose test system, you basically go to a drugstore, pay about $20 US, and get a box that can work with test strips. The box and the electronics in it cost way more than $20. The test strips are where the company makes its profit. And so they rely on you purchasing these test strips at a slightly higher price. What's happening is there are actually brands of test strips that are being counterfeited, where there are test strips which have not been calibrated and have not been authorized that can interoperate with these systems. So the challenge to that manufacturer is to make their system reject these counterfeit devices. We talked about different techniques that you can use. In general, if you have a security chip, you can do things like use challenge response, you can use digital certificates, you can use effective authentication schemes, and you can play some hardware tricks. And we talked about some of those techniques this morning.
Do those techniques carry over to the other devices that you mentioned earlier? Are there other general protections that can be applied?
So one of the most interesting things about this area is that there are many different industries that are facing essentially the same problem. And remember, the problem is that your hardware is basically incrementally free. It's the software and configuration on that device that gives you value. So, in the case of the glucose test meter, it is how the strips were actually calibrated and how they interact with the system that give the system value. In the case of digital content, it's the authorization that you have to play the video game or to watch the movie. In the case of unlocking a cell phone, it's a way to convince a phone that it's permitted to be used off-network. And it turns out that these authorization schemes are actually quite similar across these different industries.
And so, is it a method of programming the embedded system differently or better? Is that one of the practices that you advocate?
Well, securing your device against counterfeiting involves a couple of different things. The first thing you need to do is make sure that your software is good. And that's what every single talk at this conference is about. But basically, if you have a software bug on your device that enables someone to counterfeit it or reject or, to emulate a device or extract code from it, you've essentially given your attacker the ability to make an incremental break for free. That's a very serious problem. So the first thing you actually have to do is get your protocols and software right. An attacker will hopefully be pushed to do things like a non-invasive or an invasive attack. And the most of my talk was based on how to protect your device against these vulnerabilities.
Well, thank you, Benjamin, for your time. It's been informative.
Thank you. It's been an exciting show.
Okay.